Inshallah, in this class, we are going to continuing maxima and minima. I request to the students, those who have not seen the previous part, please first you go through that part, because in that part I have explained in detail the method how to find the maxima and minima. So let me continue in this next questions. We already have done 2-3 questions in the previous part. So let me start now. Find three positive numbers. Let me denote like this. Let x comma y and z be the numbers. Be the numbers. So sum is 100, therefore given x plus y plus z equals to 100. Let me find z from here. How to find z? Take the two numbers there, x and y. So z equals to 100 minus x minus y. Note this as 1. Now what is given here? Whose product is maximum? Whatever the maximum or minimum we have to find. Let me suppose this by f. Let f equals to product means multiplication, so x y z. So this we have to find to be maximum. Product should be maximum. For that we suppose f. Now let me take out z from here. F equals to x y into z is 100 minus x minus y. First let me do one thing. First let me multiply this, then afterwards let me differentiate. F equals to xy into 100 is 100 xy minus x into x square y, xy into y, xy square. Now let me find the values. We have discussed already in the previous class. Now we have to find p, q, r, s, t. What is p? Fx, q, fy, r, fxx, fxy, fy, fx, fy, fxx, xy, yy. Fx means partial differentiation with respect to x. So d by dx of x is 1 into 100y is 100y. D by dx of x square is 2x, so 2xy. D by dx of x is 1 into y square is y square. So differentiation with respect to y. So y means y is 1 into 100 is 100x. Here y is 1 into x square, y square is 2y, so 2xy. Fx of x means differentiation of fx partially with respect to x. Fx is this one. We have to differentiate this with respect to x. So we don't have x here, 0, 0. X is 1 into 2y, 2y. Fx of y, partial differentiation of fx with respect to y. Y is 1 into 100, 100. Y is 1 into 2x, 2x. Y square is 2y. So lastly, fy of y, partial differentiation of fy with respect to y. With respect to y, fy with respect to y, we don't have y here, 0, 0. Y is 1 into minus 2x, minus 2x. This is the first step. Now the next step is we have to solve to get the stationary values. We solve p equals to 0, q equals to 0. Now what we are having p here, the value of p is 100y minus 2xy minus y square equals to 0, and q, the value of q is 100x minus x square minus 2xy equals to 0. Now how to solve? Let you do one thing. You take y from common from here. Y into, it will be 100 minus 2x minus y equals to 0. We have taken y common here. In the same way, let me take x common here. If we take x common here, we left with 100 minus x minus 2y equals to 0. Now separate this one. Therefore, y equals to 0. You take minus common from this here. This will be 2x plus y minus 100 equals to 0. In the same way, you see here, separate this one, x equals to 0. You take minus common here, x plus 2y minus 100 equals to 0. See here, x equals to 0, y equals to 0. Let me don't take this. We have to find the maximum product. See here, product is x, y into z. If you put either x equals to 0 or y equals to 0, it will become 0. So the product will not be maximum. So let me do one thing. We don't get this x equals to 0 or y equals to 0, because at these 2 points, it's not possible to get the maximum value. So let me solve these two equations. One equation is x plus 2x plus y minus 100 equals to 0. Another equation is this. We know how to solve. Let I write this one. 2x plus y minus 100 equals to 0. This is one equation. X plus y minus 100 equals to 0. This is equation. Let you multiply this with 2x, x plus 2y. X plus 2y. So let me do one thing. You multiply this by 2. 2x plus 2x minus 2x will get cancelled. These are the solvings of the basics. 2x plus y minus 100 equals to 0. Now multiply with 2. 2 into x, 2x plus 2 to 4y minus 2 into 100, 200 equals to 0. Now let me change the signs. If we change the sign, this will be minus, this will be minus, this will be plus. So plus 2x minus 2x cancel. Y minus 4y minus 3y minus 200 minus 100 plus 200 is 100. Bring this 100 on the other side, it will be minus 100. Minus minus cancel. So what you get, y equals to 100 by 3. 100 by 3. Now if you substitute here, you will get x. Bring this 2 here. X equals to 100 minus 100 on the plus minus 2y. So x equals to 100 minus 2 into 100 by 3. So 3 into 100, 300 minus 200, 100. So x equals to 100 by y. Let me continue in the from the top. So next thing is we got x equals to 100 by 3, y equals to 100 by 3. Now we have to show the next thing. What is the next thing? RT minus for maximum. What is the condition we are having? One condition is RT minus s square greater than 0 or less than 0. We have to show these two conditions. So let me first find RT minus s square. RT minus s square equals to R value. R value is minus 2y into x value minus 2x minus t square s square. Sorry, s is 100 minus 2x minus 2y whole square. So let me do here. I'm continuing here. Watch carefully. I'm writing here. See, minus into minus plus 2 to the 4xy. So this is 4xy. This is minus into minus plus 4xy. If you take minus common here, sorry, if you take 2 common here, because it's whole square, no? Whole square. So 2, if you take common, that 2 square will become 4. So if you take 2 common here, it will be 50 minus x minus y whole square. Actually, you are taking common from here 2. If you take common 2, 50 minus x minus y. But 2 square is 4. Now let me take 4 common from both these two. After that, let me substitute the values. If you take 4 common, it will be xy minus of 50 minus x minus y whole square. Now let me substitute the values. 4 into x is 100 by 3, y is 100 by 3, minus of 50 minus 100 by 3 minus 100 by 3 whole square. Let me solve it in 4 into this will be 10,000. This will be 10,000. 100 into 100 is 10,000. Divided by 3 3 is 9 minus. Watch carefully. If you take LCM, this will be 3 into 50 is 150. 150 minus 100 is 50. 50 minus 100 is minus 50 by 3 whole square. So let me continue this one. 4 into minus square will be plus, plus into minus minus 10,000 minus 5 square 2500. 3 square 9. Let me take LCM 9. See here, if you minus this one, see here 4 into 10,000 minus this will be 7,500 by 9. No need to cancel everything. This number is positive. Therefore, we got the first condition RT minus s square greater than 0. So what is the value of R is minus 2. R is minus 2y. Minus 2 into y is 100 by 3. This is negative number. This is negative number. Therefore, now what we got the answer is here. Therefore, RT minus s square greater than 0 and R less than 0. Therefore, F is maximum at what is here, x equal to 100 by 3, y equals to 100 by 3. But we also have to find the value of z also, because 3 numbers are x, y, z. See here, I'm continuing here. So let me substitute the values of x, y here. So what will be z equals to 100 minus x is 100 by 3 minus y is 100 by 3. So if you take the LCM, 100 into 3, 300. 300 minus 100 minus 100 minus 200 by 3, that is 100 by 3. Therefore, numbers are 100 by 3 comma 100 by 3 comma 100 by 3. Now you see the next question. Let me start now. Find the maximum or extreme values means maximum or minimum. Now let's find p equals to fx differentiate with respect to x. D by dx of x square is 2x. D by dx of x is 1. 1 into y is y. We don't have x here 0. We don't have x here is 0. Now d by dx of 1 by x. We already seen this. D by dx of 1 by x is minus 1 by x square. So d by dx of 1 by x is minus 1 by x square. Once more you see here, d by dx of x square is 2x. D by dx of x is 1. 1 into y is y. D by dx of 1 by x is in the same way q equals to fy. Differentiation with respect to y. No y here, 0. Y is 1. 1 into x is x. Y square is 2y. We don't have x, y here, 0. D by d of 1 by y will be minus 1 by y square. Now p, q, r. R equals to fxx. Differentiation of fx with respect to x. We have to differentiate this with respect to x. D by dx of x is 1. 1 into 2 is 2. We don't have a constant x, so it is constant. How to solve this? You see here minus 1 by x square. Bring this x in the numerator. So this is minus d by dx of x power n is n into x power n minus 1. Minus 1 is plus 2x power minus 3. Bring this denominator, it will be 2 by x cube. So d by dx of minus 1 by x square is plus 2 by x cube. Once more I'll explain. Bring this in the numerator. Now d by dx of x power n is n into x power n minus 1. Minus 2 minus 1 minus 3. Now bring this denominator, the sign will be plus. The power will become plus. So this is 2 by x cube. In the same way, let me find p, q, r, s. Fx of y. Differentiation fx with respect to y. We don't have y here, 0. Y is 0. 1 just. Lastly, we got a t. Fy of y. Differentiation of fy with respect to y. We don't have y here. Y is 1. 1 into 2 is 2. This is same as this. Now just now we done 2 by x cube. So this will be 2 by y cube. So this is the first step. What is the second step? We have to solve for maxima or minimum. We have to solve p equals to 0, q equals to 0. What is p here? 2x plus y minus 1 by x square equals to 0. Q is x plus 2y minus 1 by y square equals to 0. Let me do one thing. You take LCM from both. If you take LCM, this will become 2x cube plus x square y minus 1 equals to 0. Here also if you take LCM, what will be this one? Xy square plus 2y cube minus 1 equals to 0. You do one thing, you subtract this one, you will get some answer. If you subtract this will become minus, this will become minus, this will become plus. Plus 1 minus 1 cancel. I'm adding this 2 first. 2x cube minus 2y cube plus x square y minus xy square equals to 0. Let me do one thing. Let me take common from this 2. What can we take common? We can take common from this to x square. No? We can take common. Now let me take common here 2. If you take common 2 here, it will be x square minus y cube. You take common xy here, xy. So you left with x minus y equals to 0. Now you can use this formula a cube minus b cube equals to a minus b into a square minus ab plus b square. So 2 into this a cube minus b cube can be written as a minus b into a square plus ab plus b square bracket plus what is left here xy into x minus y equals to 0. Now let me take again common. From this 2 we can take x minus y common. If you take x minus y common, this 2 is left. Now you multiply with this 2. So 2 into x square, 2x square, 2 into xy, 2xy plus xy here, 3xy plus 2y square equals to 0. Now separate this 2. So therefore one equation is x minus y equals to 0, or this is 2x square plus 3xy plus y square equals to 0. You see here, from here you will get x equals to y. You see this is like a quadratic equation, plus 2, sorry, plus 2y square equals to 0. This is like a quadratic. If you divide each term by y square, you will get like this. 2x square by y square. You can write like this. If you divide by y square, you get 3x, sorry, 3 we have taken common now. X by y plus 2 equals to 0. I will explain you. Divide by y square, x square by y square, whole square. If you divide by y square will get cancelled. You will left with x by y. So it is of a quadratic equation. But you see here, just if you want to find this, what is b square minus 4ac? So b is 3 square, 9 minus 4 into a is 2 into c is 2. So 9 minus 16, 9 minus 8 to the 16 is minus 7. So because b square minus 4ac is less than 0, this is imaginary. So no need to solve this imaginary. So let leave this one, okay. Let come here, we just solve this one, okay, because these are imaginary, we cannot take. Now x equals to y, you substitute either in either of the equation 1 or 2 here. Let me substitute this in p equals to 0. This equation p equals to 0 is 2x plus y minus 1 by x. 2x plus y minus 1 by x squared equals to 0. Let me substitute in place of y x. So this will be 2x plus x minus 1 by x squared equals to 0. You bring this minus here, 3x equals to 1 by x squared. Bring this here, 3x cube equals to 1, or x cube equals to 1 by 3, or you can write x equals to 1 by 3 power 1 by 3. Since x equals to y here, therefore the same value will be of y also. So what will be y here? Y equals to 1 by 3 power 1 by 3. So we got the values of x and y now. Now next thing is what we have to show. We have to show rt minus s squared greater than 0. So r value is 2 plus 2 by x cube. What is x cube here? 1 by 3, no? Okay, next step, let me write comma, sorry, r into t. T is 2 plus 2 by y cube minus s. S is 1 square. If you take common 2 from here, it will be 4 into 1 plus 1 by x cube. 1 plus 1 by y cube minus 1. You see here, since what is the value of x? X is 1 by 3. 3 will come here. X cube is, watch here, just now we have done, x cube is 1 by 3. In the same way, y cube is 1 by 3 minus 1. So if you bring here 3, 3 plus 1, 4, 3 plus 1, 4, 4 into 4 into 4, 64 minus 1, that is 63. So first proof we have already done with rt minus s square is greater than 0. So we will have either maximum or minimum. rt minus s square is, once more if you want to see, this is 1 by 3. 1 by 3 means the 3 will come here. 3 plus 1, 4. 3 plus 1, 4. 4 4 is 16, 64 minus 1, 63. Now let me see what is r here. R is 2 plus 2 by x cube. So this will be 2 plus 2 by 1 by 3. 3 2 is 6 plus 2 8. So what is the condition here? rt minus s square greater than 0 and r greater than 0. Therefore, f is minimum at what point? 1 by 3 power 1 by 3, comma 1 by 3 power 1 by 3. So f is minimum at x equals to 1 by 3 power 1 by 3, y equals to 1 by 3 power 1 by 3. If you substitute the values of this x and y in the f, you will get the minimum value. So if it is asked, you substitute the value of x and y in the f, and you do solve by the using calcium. No need to go, just you take from the calcium, you will get the minimum. Now see, a small question is there, f equals to x square. So let me solve this one. What is p? Fx. D by dx of x is 1 into y is y. Q fy. Differentiation with respect to y is 1 into xx. PQR is fxx. Differentiation of fx with respect to y, so with respect to x is, we don't have x here, 0. S fxy. Differentiation of fx with respect to y, means 1. Lastly, t fyy. Differentiation fy with respect to y, we don't have y here, so it is 0. First, What is the second step? We have to make p equals to 0, q equals to 0. So p is equals to 0 means y equals to 0, x equals to 0. Therefore, this is the point, stationary point, suppose is 0 comma 0. So we have to see at 0 comma 0, first we have to see rt minus h square equals to r is 0 into 0 minus 1 square equals to minus 1. So this is the question where we are getting rt minus s square less than 0. We wrote this condition, if rt minus s square is less than 0, therefore we cannot have either, we don't have maximum or minimum. Therefore f is neither maximum nor minimum at 0 comma 0, whatever point it is having neither maximum nor minimum, because rt minus s square less than 0, less than 0 condition is neither maximum or minimum. So there is another method, very easy method, Lagrange's method, Lagrange's multiply method to find maxima or minimum. So let me do few questions based on Lagrange's method in the next class.